Hello and welcome to the Cisco Support Community. Today we present a live Cisco Support Community Expert Series webcast event. During our event today, the topic will be IPv6 security. My name is Francine Richards and I'm a Web Marketing Project Manager for the Cisco Support Community. Our experts joining me today are Eric Vyncke, a distinguished engineer based in Brussels. His main current technical focus is security in IPv6. Eric has designed several secured large IPsec networks and other security-related designs. In his work for the IETF, he co-authored RFC 3585 and 5514 and is active in V6 OPS, 6MAN, and OPSEC working groups. His recent works are related to IPv6, including co-authoring a book on IPv6 security. He also authored a book on Layer 2 security. He is the current co-chair of the Belgian IPv6 Council and is well known for collecting statistics about IPv6 deployment for the last several years. He is also a visiting professor for security topics at the University of Mons, and he is an adjunct professor at HEC, the Business School of the University of Liège, Belgium. He holds a CISSP certification and is a member of ISSA and speaks frequently at international conferences. Our second expert is Andrew Yourtchenko. Andrew is a technical leader at Cisco Systems Network Operating Systems Technology Group and has been involved in networking since 1995. He specializes in the area of applications and network security, and he has spent a significant portion of his career at Cisco TAC driving the resolution of complex technical problems. He contributes to IETF and is a frequent speaker at IPv6 conferences. He actively engages with Cisco customers and partners in the areas of IPv6 transition, focusing on the transport and application levels, and is CCIE number 5423. I want to welcome Eric and Andrew. Joining Eric and Andrew today is Steve Simlow. Steve is the IPv6 PM in Cisco Network Operating System Technology Group. Steve has global responsibility for IPv6 delivery across Cisco core platforms. Steve has 18 years of experience in Cisco and 29 years in the industry. In previous roles, Steve has driven the deployment of IP multicast technologies across EMER, SP, and enterprise customers, and has worked with video, QoS, MPLS, ATM, and LAN-switched architectures. Previously, Steve was employed as a systems engineer at IBM UK and as an applications engineer in Motorola Codex. Steve lives in Edinburgh, Scotland, with his wife and children, and enjoys walking, tennis, cycling, gardening, and cooking when he is not delivering IPv6 roadmaps. Also joining us today is Tim Martin. Tim is a vertical solutions architecture and has been involved with the internet industry for more than 30 years. He achieved CCIE 2020 in June of 1996. Tim has participated in numerous industry events relating to IPv6 and has attained the Gold Certified Engineer status from the IPv6 Forum. And our final expert joining us today is Tobias Mayer. Tobias is a consulting systems sales engineer within the security group of Cisco and is based in Germany. Tobias' areas of expertise include Cisco Security Manager, Security Management, IPS, SourceFire, IPv6 Security, CSM, Intrusion Prevention, and 802.1x, Web Security, and many others. Now, I'd like to briefly outline the format for today's Expert Series webcast. Eric and Andrew will start with their presentation for the first 60 minutes of the program, and then we'll dive into the live question submissions for the remainder of the event. During our live presentation, you may submit questions to be answered by Eric and Andrew and the team of Cisco technical experts using the Q&A box on the right side of your console. The team of technical experts is well-versed in IPv6 security, so please begin posting your questions now to give them the best chance of answering them. Also, if you experience any technical issues, please post your question in the chat. We'll be asking polling questions during the webcast, and we highly encourage you to participate by answering them. You may also download a copy of today's PDF presentation using the link in the chat window. Now we'll get started with today's event. We're going to start off with the polling question. What is your knowledge about IPv6? A, my organization network is dual stack. B, I run IPv6 at home or in a lab. C, I do not run IPv6, but I know about IPv6 addresses, extension headers. D, I vaguely remember about an IPv6 training. Or E, what is IPv6? So take a moment to answer that, as that will give our experts an opportunity to tailor their presentation to your needs. And I want you to make sure to submit your questions, as we will answer them a little later in the webcast. And now I would like to hand the mic over to Eric, who will start the presentation, followed by Andrew.
And thank you for the kind introduction. So this presentation by Andrew and myself is about 60 minutes long. But to be honest, the topic of IPv6 security, describing the threats, but of course also the mitigation techniques to prevent those threats, is worth more than 1 hour. So if there is interest, we may want to propose other webcasts going deeper, because basically in 1 hour we cannot go very deep, obviously. And let's start this session about myths. There are a lot of wrong assumptions regarding IPv6 security. And let's try to debunk those. And the first one that quite often I receive is that IPv6 is new. I just deployed it 1 year or 2 years ago. And for instance, we just got the result from the poll, and I don't know whether you can see it, but about a third of all the participants and attendees in this call are running a dual stack network already, which is quite impressive. And another quarter runs IPv6 at home. So some people believe that IPv6 is new, and if something is new, it's pretty much like the two cars. Which car do you prefer to run? Is it the old one or the brand new one? That's for sure that the brand new one is not only better, faster, but even more secure. So can we apply this to IPv6? Not really, because you have on the bottom, on the right, a brand new pilot and an old pilot. And I'm taking the plane quite often for business, and I can tell you that I do prefer when the pilot shows something like 50 or 60 years old, gray hair or something like that, than the photoshopped baby driving a 747 on the right. My point here is that while IPv6 first is not that new, most of the specification dates from 1997, so the previous century, where network security was still in its infancy. We still need everyone or every participant in this call, we need to understand how to operate an IPv6 network. We have the experience to handle IPv6 security, to handle, IPv4 security, to handle IPv4 related network incidents, but we still have to learn about this IPv6 equivalent. So no, that's a myth. It's not because IPv6 is new that it's more secure. Another myth is based on the very large addressing space. I still read and hear stories telling me that, hey, Eric, as we have 64-bit for addressing space in the LAN, it obviously means that we have 2 to the power of 64 potential addresses on a single LAN, and if you scan at 100 meg per second, it will take 50,000 years to scan a complete LAN. So A, if the attacker cannot scan my network, then basically I am safe. And if you are with a security background, you know for sure that security by obscurity, so pretending to be hidden, never really works. Moreover, some addresses are still using these AU64 addresses. Remember, that's when we are using 48 bits of the MAC address to build up the least significant 64-bit of the IPv6 address, which translates into something such as, if everyone is using those kind of MAC-based addresses, then we simply need to enumerate all the MAC addresses which are included into the v6 address. So we only need to scan for 2 to the power of 48. And now, if you know the vendor of the LAN equipment, for instance, it's Apple, then you obviously know the OUE, so the leading 24 bits. Now you can only need to scan 24 bits of the well-known MAC addresses. And moreover, right, if you have a valuable service to offer to your clients, whether it's a web server, whether you have an IP phone, you obviously need to have your client and customers contacting you. So you will put your IPv6 addresses into the DNS, and you will put your IPv6 phone number into the SIP proxy, meaning now that an attacker to find you simply needs to enumerate all the DNS names or all the SIP numbers. And there are many other ways to find you anyway. So no, it's not because we have a large addressing space that IPv6 is more secure. So that's another myth. And the last one is more tricky, because at the very beginning in 97, IPv6 mandated the implementation and the support basically of IPsec, because IPsec was built and designed at the same time. But it was never mandated to use it. And 2 years ago, a new RFC, the 6434, has changed this. It says that IPsec should be supported by all v6 nodes, and even less to be used. It's mainly to accommodate for sensors, networking, Internet of Things, and so on. My point here is that first, a v6 does not mean IPsec everywhere, and we can also wonder whether if we encrypt everything by IPsec, or SSL by the way, we will be more secure. Because obviously if you encrypt everything, then some security cannot be enforced. No more firewall, no more IPS, for instance. So the recommendation of mine is really at the red box at the bottom. You reserve the use of IPsec and TLS, of course, for exactly the same usage in IPv6 as in IPv4. So meaning for some protected TLS encryption or for some remote access or site-to-site IPsec VPN. So no change over here. So that was the three big myths and that people believe. I hope that now it's clear that there were three myths that are not really relevant for IPv6 anymore. And the other good piece of news is that a lot of IPv6 security is very, very similar to all IPv4 security. This means that if you are good in IPv4 security, then you are also good in IPv6 security. That's what I call here basically the shared issues. So let's look about them. And before doing this, I would like to prepare and to ask you a poll here. It's mainly for Andrew's section when he will talk about the layer 2 insecurities of IPv6. So if you do not mind answering this polling question, which is basically how do you protect against ARP spoofing and rogue DHCP server in the existing IPv4 network? And you see the poll questions appearing now on the right end of your screen. So it will help Andrew basically to tune his network. Back to the main course, and basically the shared issue. In IPv6, we can do IPv6 spoofing, of course. You can change your v4 address, you can change your v6 address as well. And there are bogons. Bogons addresses are basically defined as addresses that should never be used as a source or as a destination. Think about the loopback address, for instance, or using a multicast as a source. You can do it as well in IPv6. So the team Kumery, and you've seen the URL pasted into the chat window, has got a complete list of all those bogons addresses. It's mainly used at the internet edge to filter out BGP routes that you receive in your peering, in case you are a service provider and you exchange route with BGP, or within the data plane to drop them. And regarding spoofing, we apply exactly the same technique in IPv6 as in IPv4. So basically, we are leveraging the routing table in the routers by using unicast IPfcheck. So for instance, if the PC on the left-hand side sends a packet with a spoofed source address, the router can look into his routing table, not on the destination of the packet, but on the source of the packet, and say, hey, if this packet doesn't have a right source address not existing in my routing table, then I drop it. This is called, in this case, loose source routing. Unicast IPfcheck. It works in IPv4, so it works in IPv6. Something which is also common between v4 and v6, and it's not always easy to understand for security officer, is how to apply a security policy on ICMP traffic. So obviously, you need to permit some of them, because ICMP is essential for IPv6 traffic to go, but you also may want to drop a few of them. So for instance, in this case, on this table, I put the comparison between IPv4 and IPv6. And for sure, both v4 and v6, we need to allow ICMP echo request and reply, that's the connectivity check. But what's new, and that's what's written there in the bottom right corner of the table, in a kind of a bluish, grayish color, is all the use of ICMP by IPv6, which is different. And when I talk about the line I'm indicating right now, address assignment, this is basically the stateless address auto-configuration, where you remember, and Andrew will go back on this later, the router is sending an ICMP messages called router advertisement, and then every node on the network gets its own address. Address resolution, this is basically neighbor advertisement, neighbor solicitation. It was done in IPv4, not over ICMP. In IPv4, it was done by ARP. Now it's done over IPv6, over ICMP, over IPv6. So what we typically have, in the case of you have, for instance, a router or a firewall in the middle here, where the red arrow is, what kind of policies do we need to allow? You basically have two parts policy, and this is described in the RFC 4890 with many more details that I can explain here in 2 minutes. So first, let's apply the access control list where the ICMP messages should go through Internet Server A. And then you see the destination is basically always A. So any traffic coming from the Internet or from the intranet should be allowed to destination A, to allow the echo request and reply, to allow as well, and it's very important in IPv6, is this packet too big. Remember, in IPv6, there is no fragmentation. So parsing to discovery must absolutely work. So pretty much like in IPv4. What's new now, and that's brand new in IPv6, we do need, if the IP addresses of the firewall, the router is B, we do need to permit some traffic whose destination is the router interfaces. The easiest to understand is the one in yellow, the neighbor advertisement and neighbor solicitation. They do replace indeed ARP request. Remember, this firewall needs to understand the upstream router MAC address as well as the downstream server MAC address. In IPv4, it was done by ARP. In IPv6, it's done by those two packet types that are ICMP. So we do need explicitly or implicitly allow them through the access control list. Thanks God, in most of the Cisco device, ASA and routers, it's done by default. So we are adding those two permits for you before the last deny any in IPv6 access control list. Something very similar as well between IPv4 and IPv6 are all those attacks. For instance, application layer attack. Whether you are sending me a spam over IPv6 or IPv4, that's the same. Whether you are sending me a SQL injection attack over HTTP, over TCP, over IPv4, IPv6, that's the same. And that's good, because most of the attack nowadays happen at the application layer. And we've got tools such as IPS, intrusion prevention system, to protect this. And as the attacks are the same, it simply means that we can reuse all the existing techniques and even signatures to prevent IPv6 attack. And this is pretty useful. And also, for instance, flooding, pretty much like a denial of service attack, usually exists as well in IPv6. So for me now, it's time to give the floor to Andrew that will explain to you more about the layer 2, what you call the first stop threat and mitigation. Andrew, the floor is yours.
Thank you, Eric. So Eric already mentioned about a couple of ICMP messages that are very important for the operation of IPv6. And we will talk a little bit about them in more detail. So one of the things that is different in IPv6 very much compared to IPv4 is how the router discovery is being performed. In IPv4, well, the router discovery pretty much is not happening, right? So you configure the router either manually or in the DHCP configuration. So it is being assigned by the DHCP server. In IPv6, the router discovery happens via a special mechanism where the host sends a router solicitation, which is an ICMP message, and the routers on the link respond to the router advertising themselves. And besides just the initial router discovery, also these router advertisements help to keep the host informed that the routers are still there on the link. So besides that, the router solicitation, router advertisement exchange also serves as a very important sign that, well, there is IPv6 router on the link. So pretty much all of the configuration of the host is tied and triggered by the router solicitation, router advertisement exchange. Now, that's the bright side of life. What if we are a black hat? Can we exploit this? And what can happen in it? Right? So much like the routers can advertise their presence on the link, they also can advertise that they're about to go offline. So they can tell the host that, hey, I'm about to stop forwarding traffic due to whatever reason, and you need to stop sending the traffic to me. So they do that by advertising themselves with the zero lifetime, so deprecating themselves. And since those messages are not authenticated, an attacker can just pretend to deprecate the active router on the link. And then after that, the attacker can themselves advertise themselves as a router. So as a result, the nodes on the link will think that, oh, well, that's this new router on the link that we need to send the traffic to. And as a result, the attacker can get all of the traffic of the users and either perform just a blackhauling of the traffic or can do man-in-the-middle attack and be able to see all of the communications. So another part that is new in IPv6 compared to IPv4 is the address assignment mechanism called Stateless Auto-Configuration. And it is a very, very interesting approach in that the hosts are pretty much, well, almost free to choose the addresses they want, with some exception, and that being the network portion of the address. So the router, when the router sends the router advertisement, tells the prefixes that it routes on a given link. And when the host receives these prefixes, they can say, look, what I will do is I will take this network address and then I will self-assign the interface identifier, so the least significant portion of the address, and together that will represent the routable address on this link. So again, this mechanism is part of the router solicitation, router advertisement exchange whenever the auto-configure flag is set for a given prefix. So you can, of course, as well disable that for the host. But nonetheless, for a lot of scenarios, this is really a convenient way to distribute the address assignment for the host and be able to do that in a decentralized fashion, because the router just sends a single packet and the host can then self-assign the addresses. Now, of course, if we put again the black hat on, we can send our own prefix, for example. And again, like in the previous case, we deprecate the active router and we advertise bad prefix, for example. So we get the host to self-assign different addresses than they're supposed to get. And as a result, we will have the host sourcing the traffic with the wrong addresses. Again, as a result, the router will typically blackhole the traffic, or even if they don't blackhole the traffic and forward it, then the return traffic will not be able to find its way back. So that was it for the router resolution. Address resolution. Largely in IPv6, from the conceptual point of view, it happens very similar to IPv4, except, as Eric said, that happens using ICMP as opposed to our protocol. So there are two messages, one being neighbor solicitation, equivalent to the ARP request in IPv4, whereas the host sends it to a solicited node multicast address of the target that it wishes to resolve into, the mapping to the Ethernet address for. And then that target, listening for this multicast group, replies with the neighbor advertisement, which contains the mapping of the Ethernet and IPv6 address. So as well, as part of this exchange, the originator of the neighbor solicitation also includes the link layer address of its own. So we can save one more exchange because the responder will likely need to talk with that node anyway. So it can cache the mapping of A IPv6 address and A Ethernet address as well. So once we do this single packet exchange, we can exchange the packets between A and B on the link without any problem. Now, of course, this again doesn't look very authenticated, and it isn't authenticated. And if we are putting a black hat on, we can indeed claim someone else's address. So all we need to do is we need to join the solicited node multicast group of the target address, and we can then hear the neighbor solicitations and reply to them with the neighbor advertisement. So of course, then once we got the host to send the traffic to us, again, we can perform all sorts of interesting activities like either blackholing the traffic, or we can perform a man-in-the-middle attack on the traffic between the legitimate hosts and the internet. So all of that, of course, calls for some sort of security mechanism. And as I said, the IPv6 is more distributed compared to IPv4. So there is no more just a single centralized server like DHCP server that can control the addressing, and also the router configuration is much more distributed. So we need some kind of another centralized approach to this, and that is centralized layer 2 security. So otherwise first hop layer security. And the first of the mitigations is the array guard. So all in all of these mechanisms are configured in the device on the network that does see all of the traffic, right? So that will be the switch, of course. And the goal of the array guard is fairly straightforward. So it has in the configuration the administrative policy onto which port in which VLAN can contain a router. So then, according to that policy, it listens to the router advertisements and then decides whether it forwards the router advertisements onwards or it drops it and doesn't forward it anymore. So if a specific port was configured as a client port, then router advertisement received on this port is dropped, and as a result, that attack that we looked at before does not succeed. So then the hosts do not get the router advertisement. Now, for the other attacks to be mitigated, we would need to understand, so what kind of addresses do the hosts get, right? So we need to see, so not only who advertises which prefixes, but which kind of addresses do the hosts get. So if someone steals the addresses of another host, how can we know that the victim did have the address in the first place? So in order to do that, we glean the address and we watch the neighbor discovery messages between the hosts on the segment, and we build the table that allows us to understand which address belongs to which host on which VLAN. And if the address changes are legitimate, then we can follow them and record the changes. But if we detect that the addresses are stolen, then we can just enforce that policy to ensure that no one takes the addresses from another host. So once we have the table, then we need to keep it current. And we need to keep it current by periodically refreshing it, right? Because otherwise, if the host goes away and disconnects, we cannot keep that address forever, because then the next host might come and even it might take the same address, and then we will be thinking that it steals the address from the old host. So what we do in this case is that for the entries that are becoming too old, we send the duplicate address detection neighbor solicitations. So we pretend to be a new host that comes on the link and tries to take the address of that host that we know about. The hosts that sit on the segment, they protect their addresses. So they reply to us, to the switch, with a neighbor advertisement. As a result, if we get that reply, then we keep the entry in the table and refresh its idle timer. Now, if we send the neighbor solicitation to a host entry and we don't get any reply after a given period of time, then we decide that, well, that host has been removed from the network, or it simply doesn't use the address anymore. So then we delete this address from the table, and some other host, if it comes on the link later on, it can use this address, and then we put it back into the table. Now, with this table that we can maintain, we can also fully enforce the source guard. So we enforce the address ownership, and we enforce a kind of RTF, but at a very, very granular level. So we can then avoid the spoofing of the source addresses directly on the first hop. So we can then, after we have the addresses in the table, we can monitor the host sending the traffic, and the first host sends the traffic. We see that the source MAC is in the table and it matches the source IPv6 address and the VLAN is correct. So therefore, we can allow the traffic to be forwarded. Then another host sends the data, and again, we have a match in the table. And then we have a third host that doesn't exist in the table. So what do we do in this case? Well, we drop the packet, right? Because that's the idea of the source guard, is to prevent the address spoofing. But we need to also ensure that maybe this host is something new that existed on the link and we didn't know about, or we somehow missed the neighbor discovery exchange that this host had when it came up online. So we want to try to trigger the learning mechanism, which will allow us to get the knowledge about whether this host does have the address or not. So then what the switch does is that, again, it tries to claim this address, and it tries to either do the duplicate address detection for this address, or it can also send the DHCPv6 message least query to the server and to try to find out whether the server knows about this address. And then again, either the server replies that, yes, I do have this address, or the client, which does have the address legitimately, it will reply with the neighbor advertisement telling that, yes, I do have this address, so I will defend it. And then based on that, we can say, okay, well, yeah, I agree, you are legitimate, so I'll put the entry into the table, and then the subsequent packets from the host will be flowing freely, so then we will forward them without any interruptions. So with this, I will give the floor back to Eric.
Okay, thank you, Andrew. And again, I'm not sure whether the attendants see the result of the poll, but regarding the layer 2 security in IPv4, about 2/3 of the participants are using some form of layer 2 security, such as dynamic app inspection. So I really encourage you to apply exactly the same thing for your v6 traffic. And let's continue with now, maybe more interesting, something which is specific to IPv6. And let's come back on addresses. You remember what I said about the fact that IPv6 addresses, we cannot scan really a network with all those addresses, but which is good for the bad guy, but there is a bad aspect on this, because most of the information security department are daily scanning the complete intranet by scanning all the v4 addresses to find new devices and running virtually scanning and nmap, for instance, against those new IPv4 addresses. In the case of IPv6, there are too many of them, so you cannot really do it. There are ways of doing it, and one way is to leverage the content of all the tables that Andrew has just explained. But there are also different aspects that are specific to v6 regarding addresses. And one, this is what we call privacy extension addresses, or also known in Windows as temporary address. Remember, in the part of the address, which is the least significant part of it, where we have in orange here, in some case, if we are using the EU64, this is the 48 bits of your MAC address. And your MAC address never change. So it allows for people, even if you change network, and since if you change network, you change the white and blue part, but you keep the orange one. So it would allow people on the internet to notice that you are the same user connecting from different networks. Hence, the IETF has standardized this RFC 4941, where this interface ID is allowed to change whenever you want. in some case on each and every phone call, or typically on the Windows and Mac OS and others on every day. Please note that on iPhone and iPad, every time the screen comes up again over your iPhone and iPad, you will get a new address. This protects, of course, your privacy, but the issue now, if we put our security person hat on the top of our head, it means that what you have now in your network as addresses are not the same addresses as yesterday. So if you want to look in your log file for web servers or whatever IPS firewall, the addresses in the logs do not exist anymore in your network. So it's quite challenging to find them back and see basically who was the PC doing dirty stuff on your network. The way to fix it again is, for instance, to disallow the use of privacy extension in the intranet. So one way of doing it, if you are using only a Microsoft Windows device, was to use all those commands. But nowadays, everyone is using BYOD, bring your own device, and has Android or other iPad, iPhone device. And those ones obviously do not have those Microsoft commands. So the easiest way to do it, and by the way, this is what Cisco internally, because we have deployed IPv6 internally in most of our offices right now, that's how we do it. We simply send very specific router advertisement where we disable the auto-configuration by sending this no auto-config, and we put a hint to use DHCPv6 by setting the mbit, so by using its manage config flag. So it simply means then you disable stateless address auto-configuration, and you disable privacy extension, and you get a hint to use DHCPv6, which is a stable IPv6 address because it's kept into the list file, and you keep using, when you are on the intranet, always the same IPv6 address. So now your log files are again valid. Another thing which is pretty much specific regarding IPv6 is all those extension headers. You remember, for instance, the simple one, that's when we have 6 and then you get directly TCP, but you may want to say the next protocol is 43, which is routing header, so pointing here, and in routing header we get 17, which means that the upper layer protocol is UDP. Should be well known to you, as you have, most of you have deployed somewhere IPv6. So what does it have as an impact? I mean, some people were fearing in the beginning that it will make the task of firewall impossible, because firewall in IPv4 look for the TCP and UDP ports always as the same offset at the packet, just after the 20 bytes of the IPv4 header. But in the case of IPv6, it's mostly the same, because if we have a very complex things like this one, most of the extension headers either have a TLV, tag length value encoding, so we know the length of all those headers, or they have a specific fixed length. So now the firewall, whether it's stateful, like ASA, or stateless, like a switch or a router access control list, they know how to parse and find, let's say in this case, the TCP header. And pretty much like in IPv4, if you receive a packet where you do not know the transport layer header, because let's say in 2 years the IETF invent TCP++, then of course your firewall access control list cannot parse this very specific transport layer. It simply means that this specific access control list entry is no match, and we go to the next one, eventually reaching the last implicit access control list entry, which is simply a deny. So don't read too much, it works pretty fine. Fragmentation is also done in IPv6 by extension header. And honestly, at Cisco Live, I have a presentation about 1 hour just dedicated to this fragmentation issue. There are a couple of RFC on this. Again, fragmentation is done by a fragmentation header, and it must be done by the source. Okay, routers never fragment, which really means that we need to be sure that path MTU discovery works pretty fine. Now, one thing that we have the same attack as in IPv4, we can have overlapping fragments, where one fragment overrides another one with a different content, and this RFC mandates to drop such overlapping fragments, and it's implemented in all Windows, Mac OS, and Android, so we are fine. But there are many, many other ways to do fragmentation. And again, if you are interested on this, please request another webcast, and then I will spend about 1 hour on this. In short, IATF has specified ways where some specific fragmentation that could bypass firewall and IPS are forbidden, and that routers and firewall can drop them, and that hosts can safely ignore them. So we are kind of safe now. But it's pretty recent, it's the last month. Other thing regarding IPv6 that are specific to IPv6 is all those transition techniques. As you know, we are not deploying v6 immediately. We deploy it by steps. One way of doing it is dual stack. Another way of doing it is transporting IPv6 over IPv4, or vice versa. Some service providers, as you know, using MAP or the old dual stack Lite, also transport IPv4 over IPv6. So many transition techniques, and all of them has got their own security challenge. And by the way, I really encourage you to ask questions into the Q&A panel. That will be the most efficient way to transfer knowledge today. For instance, when you are using dual stack, it means then your host or your service running on a dual stack operating systems can be attacked over IPv4 or IPv6. That's what I call fate sharing. As you can be attacked over IPv4 as well as IPv6, you need to protect your host and your service as much as IPv4 and IPv6. The security policy in IPv4 must be identical as for IPv6, which means multiple things. It means that the security policies as implemented in your firewall, being a network firewall or a host firewall such as IP tables or IPsec tables, must implement exactly the same security. But do not forget about the specific exception, as explained before, for ICMPv6, right? As described as RFC 4890. It also means that you need to scan for vulnerability scanning using Metasploit or whatever, both on IPv4 and IPv6. Don't forget about it. The thing is that some existing old products are basically not always configured by default on IPv6. And I will take from now the example of a VPN client, either using the very old Cisco IPsec VPN client, so not any connect, or if you are using Linux, the default Linux client, or the default macOS VPN client. In those VPN, you can configure what we call no-split tunneling. That's a centrally enforced policy forcing all the traffic sent by the PC to go inside the IPsec tunnel to the corporate network, where it will be inspected by firewall, IPS, and so on. And it also states, obviously, that all the traffic coming outside of this tunnel, such as, for instance, a botnet command and control, must be dropped. It was product design in 2000, where IPv6 was mostly never deployed, meaning that those old products, simply if they receive IPv6 packets, for instance, coming from a botnet command and control channel or any kind of attacks over IPv6, they will be allowed. So somehow they completely bypass the intent of the no-split tunneling for the IPv4 traffic. And you can find it for host intrusion prevention and multiple places, as well as routers. When you deploy a router, most of the time you apply a VTY access class to protect the router from attack over IPv4. You should as well do it over IPv6, obviously. So seems pretty obvious, right? But the thing is that I've seen multiple times And that's usually when I am facing people while explaining this. In front of them, I see a few people in the room going with a blank face. And for instance, that's the following. By default, your host is protected for IPv4 attack by using whatever your tools. And IPv6 is now enabled by default on all the Windows, Mac OS machine. And either because you are lazy or because your security officer is not aware, you do not apply the same security policy for the V6 traffic. But as your network does not run V6 explicitly, you can believe that you are safe. Okay? I know that I'm vulnerable over V6, but my network doesn't run V6, so I'm safe. This is wrong. And let me rephrase this. Even if you are part of the 50% of the participants of the webcast today that says we do not run V6 in my network, actually you are already exposed to some IPv6 attack. They are obviously local. Remember what Andrew told you about the route advertisement? It's enough for anybody into your LAN, so it must be local, it's not a remote attack, to send a route advertisement and all your PC and phones configure for IPv6. Moreover, you probably remember that every IPv6 host has its own linked local IPv6 address. So it could be attacked against this. Again, V4, V6 are mostly identical, right? V6 is no more dangerous. What's the danger in this is that your network doesn't run V6 for sure, but your host run V6. And host can be attacked over V6 then. Or you simply move to some hotspot in an airport or a train station where IPv6 is enabled, and then you are exposed to attack coming from remote, from the internet. Again, it's not bad against IPv6. The only issue here is that your security officer does not realize that he can be attacked over V6 locally and does not protect you. So, are we left open with all the attacks now? No. We can enforce some security policy. And again, this is typically on this slide. I cannot go through all the support, of course, but both Toby, which is one of the experts and panelists here answering questions, knows a lot about ASA, the firewall running IPv6, as well the IPS, as well as the next generation IPS from SourceFire. All of those runs IPv6 for many, many years. ASA was one of the first firewalls supporting V6 and one of the first firewalls being certified for use by the US government. Even now, the email security appliance, so the anti-spam, also supports IPv6. And I am running my own IPv6 email server, and I do receive some spam over IPv6. So those things exist. My point here is that when I started working on IPv6, it was before 2005, my web server was completely open over the internet. I mean, there is no firewall protecting it over IPv6. It was fully open. Now in 2014, when you deploy your IPv6 network, whether it's on the intranet or the internet edge for your email and web servers, you simply do not have any excuse not to protect it. The tools are there. And at least on Cisco devices, it's included. So if you have a firewall for V4, you have a firewall for V6 for the same price, right? That's not a single penny or cent to pay in addition. And the same thing applies for all the VPN, because obviously you will need to connect either over public network, which is IPv4, which is mostly the case right now, or in some case, an IPv6 only network, pretty much like the T-Mobile in US, which is the 3G and 4G running only IPv6. And you want to do techniques for VPN like site to site, so branches to branches, for instance, a branch to the headquarters, or to provide remote access, so a user in a hotel, for instance, connecting to the central site. And basically the point is there here. On remote access, you can use the AnyConnect client to do it over SSL VPN, or in the case of site-to-site, the best way for doing it is to using the dynamic multi-point VPN. And again, on this, we can spend about 1 hour in a subsequent webcast if you want more information on this. As we reach close to the end of the session and basically the open Q&A with verbal replies, I would like to ask you the following polling question. And I will give you, after the poll, my own feeling on this. It's whether you believe that IPv6 is more secure than IPv4, thanks to IPsec, whether V6 is more secure than IPv4 for many reasons, or that IPv6 is less secure, or they are roughly equivalent, or simply you don't care because I don't run IPv6 in my network. But remember what I just said a couple of slides ago. So in summary, and again, it's not the end of the webcast, we have many more questions to come. Key takeaway, and I think really that's very important. There is nothing really new or it is shaking new in IPv6. Right? A lot of things are similar. So basically, what you have learned on the job, by maybe making a mistake or attending training or gaining experience on the field for IPv4, most of it, 99.5%, applies as well to IPv4. For instance, the Reconnaissance. Yes, we cannot scan a V6 network, too many V6 addresses. Not always good because you want, as a security person, want to make an inventory of your network. So we cannot scan. So you need to play tricks by using the table from First Stop Security. And basically, the address enumeration is replaced by DNS. All the spoofing and bogons are also identical in V4 and V6, and the mitigation techniques are the same. And we replace ARP spoofing by neighbor discovery spoofing, and nowadays we've got the same security as in IPv4. Minor changes is in this ICMP security policy because you need to update somehow and make a different, slightly different security policy for V6 to allow this neighbor advertisement and neighbor solicitation. Extension headers, yes, firewall and access control list can process them. In some cases, there is a performance impact. For instance, on a normal ASA, filtering V6 traffic includes a drop of performance of about 10% in throughput, which is perfectly acceptable, obviously. Remember what I said, and this could be a topic of another webcast, some fragmentation can cause trouble with extension headers. And all the next generation IPS and firewall can detect and filter application of IPv6, so we are fine. My major concern, and that's, I think, a real good reason to start deploying IPv6, at least within the lab, is to get training. Even if access control list and policy is identical, the way to find the bad guy and to mitigate is identical. I guarantee you that the first time a security operator in your network will get an IPS alert or a syslog event with an hexadecimal IPv6 address, maybe the bell will not ring and will configure this is garbage and will ignore maybe this alert. Again, nothing fancy here, but training is required. And start now, not in 2 years, right? So it's really important to deploy V6, at least in the lab. And the good sign, all the firewall and so on, as I said before, works. So you have no more any excuse not to secure your IPv6 traffic. IPsec. IPsec exists in IPv6, pretty much like SSL exists for IPv6, obviously, and use them, IPsec and SSL, exactly for the same place and the same utilization and the same use case as in IPv4. So mainly web server traffic that needs to be encrypted for e-banking, for instance, or site-to-site or remote access VPN. Again, experiment with IPv6 as soon as you can because you want to avoid being trapped by mistake, by ignorance. For the 1/3 of the people believing that you do not have IPv6 in your network, I'm pretty sure you have. So it's very easy to check. So most of the, for instance, IPS system can be used to discover if there is any ICMPv6 traffic. And you may want as well to look for traffic like using NetFlow, like protocol 41, which is mainly used for 624, but also for many other IPv6 over IPv4. To this IPv4 address or to this UDP port, which is yet another tunneling. And tunnels, again, I have no time to cover this in detail. Tunnels are most of the time, whether they are specifically the ones that are automatic, so not done on purpose by the network operator, but done automatically by the host operating system, is bad. Okay, because then in this case, it may escape some naive IPS or some naive firewall. So the best way to prevent automatic tunnel is to deploy v6 again. Another way of doing it is not on the slide here, but it's pretty obvious. You simply run a sniffer on a span, on a remote span port of your switch, and you look for v6 packets by using the header type, which is 86DD in hexadecimal. And remember what I said? Even if your network is IPv4 only, the fact that you have IPv6 host simply is a clear indication that you have IPv6 potential threats. So you need to protect, you need to deploy IPS, and you need to understand IPv6. Again, don't read too much. Running an IPv6 network is now well understood and well documented, and we can go in many more webcasts if you want. Recommended reading, if you don't mind. This one by Shannon is mainly about how to deploy v6 in the enterprise network. Alexander has written a book on Cisco Firewall, and myself with Scott Hawk, we wrote a book about IPv6 security. It's dated now 4 years ago. It's kind of old, but still the content apply at 95%. And even if it's Cisco Press, it applies mainly to any IPv6 network. With this, Francine, I have finished my part. I don't know what do we do for the final Q&A right now, or if you have other things to say to the attendants.
Okay. Well, thank you, Eric, and thank you, Andrew. That was a great presentation. I want to also thank everyone for participating in the event polling. We're going to answer some of the questions our viewers had submitted today, and if you can't stay with us for the Q&A, please be sure to click on the evaluation link provided in the chat to let us know how the session met your business needs and expectations. So the first question here, let's go ahead and go to the Q&A there. Okay. What about send and CGA?
Okay, so I think, Andrew, this is more for the layer 2 parts, so up to you. Yeah, so I think I could discuss this. And indeed, send and CGA do exist, but they primarily exist on the routers. And the support on the end systems is pretty poor, if existent at all. That's one side of the problem. But then the other side of the problem comes that with CGA, you start to have the benefits only when all of the nodes in the network, well, or on the segment, are running the CGA and send. So once you have the host that is not running the CGA and send, you have a choice that you need to make. So is that a node that does not support CGA and send, or is that a node that wants to get in and use a non-CGA address? So that makes the maintenance and that makes operations of the network not so easy. So that's why we did not put too much emphasis on the CGA and send, and we focused on the centralized approaches.
Thank you. And we have another question here that's, when will Cisco by default block extension header options which are not valid?
So maybe I will take this one. So first, a router doesn't have to block transit traffic. A router is there for forwarding. So as long as you have a correct IPv6 header, it will be forwarded. Now, what you can do in iOS access control list is to specify the list of accepted extension headers or that are accepted or dropped. And the same apply for ASA, except that for ASA, if there is an extension header which is not the default ones as specified by the IETF, the packets will be dropped because the firewall should drop bad traffic. So in short, firewall drops unknown extension headers, routers do not drop unknown extension headers, but you can usually configure firewalls and routers to permit or deny specific extension headers.
Thank you. And the next question here is, there are over 24 transition types today, so that I think they want you to expand upon that.
Yeah, I mean, the transition techniques are many. The most common one is, of course, the dual stack, when you run native IPv4 and native IPv6 on the same network. And as I said, it's the main issue is to get congruent security policies for v4 and v6. But there are many more. And the many more are mainly around either translation technique, like NAT64, when you initiate a connection of a v6, and then at some point of time you NAT it into IPv4, because it's the same TCP and upper layers on the top, which has some challenges because you are sharing some IPv4 addresses. That complicates, obviously, all the auditing and the logging. And the last class of transition techniques is all the tunnelings. And tunnelings, and the way I speak to the questions in Q&A, there are many. The most dangerous ones are the ones that are automatic and built-in Windows, such as Teredo 624. Because by default, they will be used for some application, very specific application. Nowadays, it's not so much a threat, but it was an issue a couple of years ago where Windows would start very rapidly and for nearly no reason a 624 tunnels. And those tunnels, in some case, can bypass firewall and IPS if those IPS are unable to look inside the tunnel. But for instance, with Cisco routers, NetFlow can provide you about visibility and control of what's inside those IPv6 over IPv4 tunnels, or vice versa. So the three classes, dual stack, translation, and tunneling, each having a slightly different condition and threats and mitigation techniques.
Okay. And this next one talks about how IPv6 does change the security models we use in IPv4. So your presentation talked about that a little bit, but I think they just want you to expand a little bit on that.
Okay. So basically, and I think most of the people reply at the poll, by the way, by the answer D. So 60% says v4 and v6 are roughly equivalent regarding security, which is also my point of view. So v6 doesn't change heavily compared to IPv4. There are minor changes regarding the layer 2. That's what Andrew explained. There are minor changes regarding ICMP, and extension headers has some of their own challenges, specifically fragmentation, but those are more and more understood, and mitigation techniques are there for wrong utilization and wrong use case of fragmentation. So honestly, I would say it doesn't change a lot, but the only thing to remember, and I will repeat it myself, your security officer must understand IPv6 security now, or actually since he introduced or you introduce Windows Vista in your network. Because as soon as you have a v6 host in your network, you are concerned by IPv6 and you must understand IPv6 security. So basically, no big difference, honestly, there.
Thank you. And does Cisco now offer blacklists for the email devices for IPv6?
Good point and good question. So that's indeed a kind of a place where currently, and it's not only Cisco, it is the complete community, where we are using IP address reputation. The example, which is classic, for instance, and sorry if there is anybody from Nigeria, in the call, but an IP address based in Nigeria is most probably more, the probability to send spam is higher from those addresses than, let's say, addresses from Belgium, my own country. Again, and you can understand it by, it's not based on country, it's based on service provider anyway. So yes, we have very good database on this for IPv4. Even now, with as service providers deploy more and more NAT, they call carrier-grade NAT, to share the remaining IPv4 addresses in their pool by many, many customers. So the reputation, whether good or bad, is diluted for IPv4. So the reputation database in IPv4 is a quality which is going down. In IPv6, those databases exist for, let's say, 1 year or 2 years now, but they are brand new, simply because the utilization of IPv6 over the internet is still reduced. I mean, about 3.5% now have IPv6 at their computers. So we do not have a lot of knowledge yet, and I insist on the yet, to build those databases. So they are really in their infancy, and we do not have yet too much of IPv6 reputation database for, let's say, email spam, anti-spam appliance. On the other hand, as I said, for the team Cumulary, into the anti-spoofing and bogons, there are a list of white addresses, basically the white list of addresses that you should allow, and obviously the other one is the blacklist. So, but based simply on the fact that this address is, for instance, a loopback address and should never appear as the source, or this address is a multicast, should never appear as the source, or this address is not a valid IPv6 address. So for this, we have black and white list coming from Team Cumulary or from the IANA.
Okay. And will the OSPF for IPv6 be fixed to support interoperability between other vendor products?
Okay. I guess there, it's OSPF v3 per se works fine with multiple vendors, but except for one thing, which is the authentication. Obviously, you want to protect your routing protocols by using HMAC, for instance, this hash message authentication code. In OSPF v2, which is the one for IPv4, it's done within the protocol itself. When OSPF v3, which is OSPF for v6, has been specified many years ago, the intent of the IETF was to simplify all the protocols, and they require the use of IPsec in transport mode to authenticate OSPF v3. The beauty of it is that you can also use not only AH in transport mode, but also ESP. So meaning you can encrypt also your OSPF packets in addition for authentication. So it was a kind of an added value. Now, not everyone was using this method of authentication. And also some people were not so happy of having to configure IPsec, even if it's an IPsec without IKE or ISACAM, so no certificate, no shared keys or whatever. So very simple configuration, no cryptomap, so very, very simple configuration. But some people wanted to reverse and go to the old way of putting the HMAC within the OSPF v3 protocol itself. And now there is an RFC for 2 years, maybe 3 years now, allowing this. And indeed, not every product in Cisco and maybe in other vendors support this brand new authentication scheme. Now, if Steve Simler, which is one of the panelists, could say more either now on the phone or into the chat window, because he should know maybe some roadmap for OSPF v3 with this new authentication for iOS.
Okay, and there is a question again about Send and CGA. They're saying that Send and CGA work great on Linux, OS X, and BSD, but not on Microsoft products without add-on products. Can you elaborate on that?
Andrew?
Yeah, so that was what I was saying about inability to have all the hosts running it. And as far as I know, there was an add-on which was being developed by a university in Germany, but correct me if I'm wrong, but as far as I know, they still haven't released it. So that's a bit indeed unfortunate.
Okay. And here's a question about denial of service. Was there any IPv6 denial of service attack yet?
Oh, yeah. And for instance, I know about a couple, but the best one, I think, the most fun one, was against Cisco. So Cisco.com, obviously, we are getting maybe not daily, but at least weekly, a couple of denial of service attacks against Cisco.com. I think we are pretty visible target. And they were, I would say, mostly happy. The InfoSec department, the Information Security Department of Cisco, I think it was in November last year, 2013, when they said to me, "Hey, Eric, we've got our first DOS over IPv6. And the thing, of course, is that I think our DOS for IPv4 by botnets and distributed denial of service are about 20 gigabits or more of IPv4 traffic. The one over IPv6 was a mere 50 megabits, so basically 1,000 times less. So it was not really a DOS, obviously, because all our infrastructure can sustain this very easily, but it was simply our net flow collectors and triggering alerts on this. But anyway, there have been some attacks, DOS attack, again IPv6, and the detection techniques is the old one, so it's still net flows or SNMP counters, and the mitigation techniques, pretty much like using Radware or Arbor networks, Cisco partners, works now with IPv4 and IPv6. And for instance, as well, a lot of DOS attacks are handled by CDNs such as Cloudflare or Akamai, and those two can also do DOS protection over IPv6. So the threat is still there, and the mitigation is exactly the same. So don't forget about it, but don't worry too much.
Thank you. And if my switch does not support first hop security, do I have other mitigation techniques against rogue RA?
Yeah, obviously you do have other means if you are able to configure port access lists. So then you can have kind of RA guard light if you permit only the traffic that you want to see on those ports. So you'll need to carefully look which traffic needs to be on the ports, and then obviously on the client ports you permit router solicitations, neighbor advertisements, and the user traffic. And this way the router advertisements from the client ports will not be able to come through. So of course this is additional configuration work, so that's why array guard may work better in some scenarios. But yes, if the switch supports the port access list, then you indeed have that possibility. So if you have a switch that doesn't support any port access lists altogether, or if it is not a switch but a hub, if you still have it, then, well, really one of the most critical parts, which you still probably would need to do anyway, is to monitor what is happening on the network. Because really that's, I think Eric mentioned it not once, but many times as well, is that monitoring what is going on the network is really one of the critical pieces, and that is invaluable to see what is going on. So then, of course, then the mitigation part will be more manual, and that will involve finding the host and then fixing.
Okay, and then one final question. Is there also a threat about rogue DHCP servers or server?
Yes, so there is a possibility to have the rogue DHCP server, but the DHCP requests from the host are controlled by the array in the first place. So that's why we put more emphasis on the protection from the rogue arrays. But indeed, there is mechanisms similar to array guard, so that's DHCP guard, and they're typically pretty much bundled together that function very much similarly to array guard, because then they prevent the host from sending the packets which were supposed to be sent by the DHCP servers.
Okay, thank you. And that's going to conclude our Q&A portion of today's event. We will have an Ask the Expert event with Eric and Andrew. So if you have additional questions or didn't get your questions answered today, you can go ahead and go to that. So they'll be able to answer your questions. You just log into the Cisco Support Community, go to the Expert Corner, and you can find their discussion in the knowledge sharing section, or you can click on the link provided in the chat window. And now we're going to have our trivia question. What does the Amazing Spider-Man 2 and Cisco share in common? A, Sony Pictures, producers of the Amazing Spider-Man 2, used Cisco routers and switches that are IPv6 certified to support their long-term next-generation ICT infrastructure strategy and solve their growing business productivity. B, Cisco sent a tech team to Sony to collaborate on the most efficient web-based technology to use for the making of the Amazing Spider-Man 2. C, Mark Webb, who directed The Amazing Spider-Man 2, was a Cisco employee at one time before shifting to directing, and Mark helped collaborate on various products such as Cisco switches during his time at Cisco. Or D, Cisco has product placement throughout the new film, The Amazing Spider-Man 2. So go ahead and take a moment to answer that question, and we'll reveal the correct answer a little later. We have several upcoming webcasts coming up, and we'll be pasting the links to the registrations in your chat window on the right-hand side of your console. So the first one is in Portuguese, and it's IP Multicast. It will be held on Wednesday, May 7th at 11 a.m., and that's Brazil time. Our next webcast is in Japanese, and the topic is going to be Internals of Cisco ESA Scan Engines, and that webcast will be held on Tuesday, May 13th at 10 a.m. Tokyo time. Our third webcast is in Russian, and the topic is Basic Device Provisioning Configuration and Common Issue Troubleshooting when using Cisco TMS Provisioning Extension. And that webcast will be held on Tuesday, May 20th at 12 p.m., and that's Moscow time. And our final webcast is going to be in English, and that is on Intercluster Lookup Service and Cisco User Data Service Interworking for Service Directory. That webcast will be held on Tuesday, May 27th at 11:30 a.m., and that's India Standard Time. We also have some Ask the Expert event discussions that are currently running. The first one is on Cisco UCS B service latest version and its new features. The second one is Wireless 802.11ac, and that's on configuration and client interoperability. These discussions both end on May 9th. And if you haven't already logged into the Cisco Support Community recently, we encourage you to do so. We have a brand new look and feel, so log in and start sharing today. And of course, be sure to join the Cisco Support Community where you can share current real-world technical support knowledge with your peers and experts. Also, be sure to check out the Class of 2014 event top contributors on the Cisco Support Community. If you're interested in conducting an event for us and becoming a top event contributor yourself, please go to the Expert Bureau and sign up. And our presence in social media, iTunes, and Google Play keeps expanding, so we encourage you to visit the community and join us through these channels. As you saw from the upcoming webcasts in different languages, we continue to expand our reach in many different languages. We have also recently launched our brand new Chinese community, so please be sure to stop by and browse through it if you do speak Chinese. And take a moment to rate the content of your peers' documents, videos, and blogs. In doing so, you help us recognize the wonderful content that they contribute. And the Cisco Support Community also is inviting you to join Cisco in lending a hand to Kiva, the nonprofit service. It services the needs of poor, vulnerable, and or excluded populations, either through financial services or by using credit to expand access to beneficial products and services at 0% interest on a global scale. The program is simple. Each time you rate content, mark questions as answered, update your bio, vote, tag, endorse, and share using social media, we'll donate $1 to Kiva. The program will run for 90 days or up to a maximum donation of $10,000 US, whichever comes first. So help the Cisco Support Community, help Kiva by going to the community and rating and participating. And now the answer to today's trivia question, it was A, Sony Pictures, producers of The Amazing Spider-Man 2, use Cisco routers and switches that are IPv6 certified to support their long-term next-generation ICT infrastructure strategy and solve their growing business productivity. So before signing off, please take a few minutes to complete your evaluation of today's session, and it will help us address your business needs and interest in the future. And this concludes our session today. I want to thank Eric and Andrew for sharing their expertise with us today. I also want to thank our experts Tim Martin, Tobias Mayer, and Steve Simlow for answering your technical questions. And I want to thank our audience for attending and wish them a wonderful day. Thank you.